Hello everyone, hope you all are doing great. Very good morning, good afternoon, and good evening to all who all are joining us globally. I am Partharu, Events and Program Manager for Microsoft Reactor India. And yes, I once again welcome you all to our today's episode introduction to Azure Kubernetes Services with modern app management. But before we start our today's event, let's go through our code of conduct. We are all here to learn together, participate together. So please be respectful of other people's views, understanding their differences. Be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section and we'll pick it up from there. Now, I would like to bring in Chaitanya. Hey, hi Chaitanya, how are you?
Hey, hi Parth. Good morning. How are you doing?
I'm all well. Chaitanya, let me give you a short intro of yours to our audience.
Sure. Yeah.
Folks, Chaitanya has around like 8 years of experience where he is passionate about cloud technologies and he has a very strong interest in distributed system and has a very good hands-on experience working with Azure Kubernetes. And he's currently at Microsoft with the team. And yes, Chaitanya, the floor is all yours.
Hey, hi. Sure. Great. So, good morning, everyone. So I'm part of Microsoft. Like, I've been working with hybrid cloud team here. So, for the past 2.5 years, and like I've explored Kubernetes on Azure a bit. So, as part of the Reactor session today, I'll be going through the introduction of Kubernetes and like how what are the different components of Kubernetes, and then like a command line tool through which you can access Kubernetes cluster that you have deployed on Azure. And post that, we'll look into a small demo, right? Like how you can deploy a cluster and see the different components of that cluster, and then and like access the code that you have deployed on the cluster as well, right? So let me quickly go through the presentation and then we'll start, right? Okay. So this is the agenda that I have already discussed, and like quickly let me like jump into the introduction of the Kubernetes itself, right? So as you might have heard of, if you have like explored Kubernetes or AKS or Azure Kubernetes, Azure Managed Kubernetes, you would have heard these terms a lot, like open source platform or lifecycle management, orchestration, self-healing, high availability, and scalability, right? So let's spend some time on what all these terms mean, right? Like Kubernetes itself started as an open source community for, let's say, if you have applications at large, right? If you want to deploy a lot of, if you want to deploy your application at scale, when you have like a lot of people accessing your application, and there is, let's say, a part of the time uh, where a lot of users come in, and at the part of the time when there is less traffic flow onto your website, right? Like then how do you control? And then that is one part of the Kubernetes. Like it helps in scaling, automating it, that scaling part, and then bringing down the application to a stage where it supports less traffic as well. So that is one part of the Kubernetes. And then the other part is like lifecycle management itself. So let's say when you have to deploy your application again at scale, so you have to replicate the service, right? Like you once it, let's say it has only two hosts in running, and when you have to run it on multiple hosts like support traffic at scale, then how does that Kubernetes does is the entire life cycle management from bringing the application pods up and then to support that traffic, and once the traffic comes down, like bringing back the application to a scale where that you need. So entire life cycle management is also done by the Kubernetes, like bringing that pods and the nodes and then killing it back to the state where you require, right? And the third, like container orchestration. Container orchestration means that like now you will be deploying your applications in the form of containers. So now let's say you have number of hosts, either it could be physical machines or VMs, and now Kubernetes helps in orchestrating all those machines and then deciding on which storage to take, right? On which VM or which wherever the space is available on the host that you have like pulled in for that instance. So that orchestration is also done, but the Kubernetes it supports that orchestration. And self healing means that let's say now you let's say in your deployment you define that you need like 10 10 hosts or a 10 replicas of one service to be running to support your traffic, right? So it will make sure that at a given point of time, at least that number of services are at that number of replicas of that service are running, right? So let's say if one of the 10 goes down, so it will make sure that it will bring up that replica on a separate host that you have as part of your orchestration, so that at a given point of time it will make sure that you have that number of instances running. So that itself also translates into high availability. So even whatever the hosts that are available as part of your Kubernetes cluster, it will make sure that all of this replicas or the instances of your application are equally distributed across all those nodes or all those hosts that you have, so that even if one of the hosts goes down, it will make sure that application is accessible through the other hosts that are part of the cluster, right? So and at the same time, based on the traffic pattern that is coming, you can set some parameters on the cluster to scale the cluster as and when needed. So this is at a high level of what Kubernetes stands for and what it helps you to do, right? So I'll quickly jump into the architecture part of the Kubernetes. So we have, so if you have any questions, please post on the chat. Like I'm on the presentation screen, so I'll take all the questions towards the end, right? So now I'll quickly jump into the architecture part. So Kubernetes architecture is mainly divided into two parts. One is the worker nodes, and other is the agent nodes, right? So worker nodes is where you deploy the your application code. So if you see on the right, it is split into three different parts, right? One is the cluster itself, and then you see a node pool, and then you see a node, and then you see a pod. So I'll just quickly describe what all these terms stand for. So pod is like a smallest deployable unit. So like pod is where your actual application code would run in the form of a container, right? So you would like containerize your code using different containerized tools like Docker or any other containerized tools that are available. So once you containerize, it's like a smallest unit possible, and that container is uh, on top of that container you create a pod, right? So pod is like a wrapper around your container code, right? So and that pod is what gets deployed onto the cluster. So nodes are like hosts. It could be either a VM or it could be a physical machine. Sorry, it could be a physical machine or anything. So let's say you have like three VMs. Here in the blue side you see like three VMs. It could be three VMs, and then each VM you call it as a node, right? So and that node when combined together it forms a node pool. So let's say you have different requirements for different applications that you want to deploy, right? Let's say one app that you want to deploy needs a higher RAM and a higher storage, and or a different version of let's say underlying OS that is running, right? Let's say for one application that you want to run, you would want Linux to be available, and other applications that you want to run, you want Windows to be available for that, or a specific flavor of Ubuntu or any other OS, right? So now what you do is when you create a node, we will see in the demo as well. When you create a node, you select the type of OS, underlying OS also that you want to deploy for that node as well, right? So node, and let's say when you group particular type of nodes, it becomes a node pool. So this, let's say the first node pool can be a type of Linux, and the other node pool can be a type of Windows, where each node underlying VM, which is part of that node pool, will have a different OS and different VM SKU in terms of RAM and storage, right, or CPU that it supports. So you can create different types of VMs under the different types of node pools with different specifications under the same Kubernetes cluster. And so now this is on the worker side. So now this you will set up in AKS or any Kubernetes wherever that you are deploying, right? Either on a physical host or on the cloud. You will be able to deploy based on the specifications that you need. So now once you have created this cluster with different nodes and node pools of different types, it comes to the deployment part, where is the pod code, where is the code gets deployed in the form of containers and pods, right? So that we'll see in the components part. How do you create a pod, and then how do you create a deployment, and on top of it a pod, and that how it gets deployed. So I'll just quickly jump into the second part of the architecture, which is master nodes. So master nodes is like a control plane, right? So control plane of the cluster itself, or you can call it as a brain of the cluster. right? So how, let's say, whenever you want to deploy something onto your cluster, how does that get wired? And let's say if you want to scale your pods, right? Let's say now earlier you had like one instance of your service running, then you want to scale that part of the service, right? Or you want to increase the number of parts of that service. So let's say we'll take an example of any other e-commerce website. So there is a lot of load that comes onto the home page, right? Whenever people just search some e-commerce website, then they directly land on the landing page of that website. So and then few people would be exploring the product pages, and then like very few people would go to the payment flow, right? So based on these patterns, you would want to have a lot of pods deployed for the pages where there's a lot of traffic coming. Let's say the home page, like the in home page part of the code, wherever it is deployed, you want to scale that. And let's say you want to have less number of instances of the payment service running, right? Because it's generally even if you go to any other e-commerce website, most of the times people would be just going through the product pages, and very rare that they would go and complete whatever have been added to the cart. They would like, if you see that pattern, it would be like three-fourth, one-fourth of what the orders get completed in general. Like just people explore the different types of products available. So based on the traffic patterns that you see on the different services, you would want to scale, right? So entire whatever commands that you issue to scale the pods, or let's say you want to schedule a different type of the payment service to be up and coming and running, right? So all that configuration and that is done by the master node of the Kubernetes. It is also, it gets deployed in the form of a node pool on the cluster itself, though it is separate from where your code would be running. So it is intended to keep that master node pool is separate, and the app code that is running, should that node pool to be separate, right? So all the traffic that has to be routed to your application code also would pass through master node. So the four major components that are part of the master node are API server, control manager, scheduler, and etcd. So let's discuss about these components in specific. Right. So API server is where which is responsible for routing all the traffic that has to pass through. So let's say you have some Kubernetes API, right, UI, and or let's say you use some command line tool to access the current state of the clusters. All those command line will commands, or the current state that you want to see, commands that you issue, or REST API commands or anything, that will pass through the API server to enter the Kubernetes control plane, right? And control manager is, let's say now you have different nodes that are running as part of the cluster, right? Where each node has different pods that are running, and you have defined like state of each pod, right? Like you would need like 3 instances of one app to be available. Let's say payment service, like for in a e-commerce store, you want it at a time three instances of that service to be available. So controller manager is something which is responsible for making sure that current state is valid always, right? So even let's say one instance of that payment service goes down, where is intended it to be 3 instances, it will make sure that it is bringing that one other instance on a different node which is healthy, right? So there it will see enough RAM or enough storage is available, and then it will bring up the instance on that node. Right. So scheduler is, let's say now whenever you are checking the status of your cluster, and let's say you observe that one of whatever the intended state, one of the pod is not there, or let's say for the payment service. So scheduler will issue a command that whenever control manager issues a command to scheduler, scheduler intent will go through again through API server to interact with the kubectl and the kube proxy. So worker nodes are part of a separate node, right? Node pool, and control plane is a separate node pool. So you would need some sort of an agent, right, which is present on the node to manage the containers and the pods that are present on that node. So kube proxy and kubelet acts as those agents on the node, which gets command from like the control plane, which are API server, scheduler, and control manager, to make sure that node is healthy, and then again whatever statuses that it has on the in terms of pods, and that are also getting reported back to the control plane of the Kubernetes. So the kube proxy and kubelet are the agents that present on each node, that gets like deployed as when you create the cluster, and they interact with the container runtime on the node to make sure that pods are healthy and your pod is running as expected. And whenever there is an issue with the pod, that will get reported back through the API server through the container runtime. And these all kubeproxy and kubelet and the other major main components of the control plane will make sure that your cluster is in always in healthy state, right? So what does etcd mean here is it's like a cluster brain, like it has the all the. So let's say when you are deploying different services, right? One could be payment, one could be ordering flow, and you have said like I need 3 instances of ordering flow, 5 instances of the payment. So all that metadata is stored in the like etcd storage. So it makes sure that so all this API server scheduler and control manager will interact with the storage and always check the cluster health statuses, pod health statuses, how many pods are required, and all that current stage of the cluster, everything is stored in the etcd. So whenever you issue commands, let's say you want to see how many pods are running, how many nodes are running, how many deployments are active. So everything is read through this storage, and it's passed on to the UI or the command line from where you are issuing the commands, right? So these are at the so again, like master node here in this picture on the right side, it shows that we have only one node of the master node running, whereas you see worker nodes, we have like different 3 node pools that is showing. But in general, when you deploy in the production mode, not as a test instance but as a production instance, you would have like you would have a replica of the master node as well, right? Because master node itself can go down, and in that case your cluster itself will become inactive, right? Because every call to the worker nodes will pass through master node. So master node also responsible for routing the traffic, right, through control plane. So if control plane itself goes down, the cluster will be inaccessible till your control plane comes up. So when the AKS is deployed in a production mode, it will make sure that there are enough replicas are also present for the control plane as well, right? So yeah, that's on a high level what master node is. So I'll just go. Now I'll be quickly discussing about the different K8s components, right, which are in general like required to make sure that you deploy the code and you have deployable code. And then once these all major components are required for that service to be accessible from a Kubernetes cluster. So we'll discuss these 3 or 4 components which will help us deploy on the Kubernetes AKS. And we'll see all these configurations are also as part of the demo and in the Azure UI as well. So what does service is? Service is an abstraction over a set of pods. So let's say now you have deployed, right? Let's say some code you have deployed on the cluster, which is a part of the container and is part of a pod, right? So one pod is an abstraction over a container. So let's say you could have different you could have used different containerized like different containerized applications to containerize your code. Like one could be Docker and any other which containerize your code, right? So pod acts as a abstraction over the container. So pod acts as an abstraction over your container, and let's say now you have different set of now you have, let's say, 3 pods running for that one instance of your application. So how do you route traffic, right, to that specific pod of the to the specific application, right, endpoint? So now whenever a pod gets created, pod itself will have one IP address attached to it, but pod is ephemeral, right? So it can go down anytime, and it can go down, it can kill, and it can be like come up in another node wherever the space is available. So let's say if you are running some process on your pod and it takes too much memory which is not available on that node, it will get killed or it will get restricted by the node, right? So and then it will move to another node which has enough space, right? So in that case, your pod IP will keep changing, and you have different set of pods based on your application needs. Like it could be 2, 10, and 100 number of pods that are running for a specific app, right? So how do you route traffic when the IP endpoint keeps changing whenever a pod comes back up, right? So in that to resolve that issue, we have a service in place, service concept of the Kubernetes. So service acts as a one more layer on top of all the pods, which has a stable endpoint. So when you deploy a service, like it gets IP and it itself will attach to all the pods through a deployment config file. So when you're creating a deployment, you mention the service name also as part of the pod deployment file, right? So that in that way, service get attached to all the pods, and through service, it routes the traffic to all the pod endpoints that are present in the cluster. So now it could be different types. So let's say I have here two types mentioned. There are more types as well. Based on the needs, we need to pick the type of the service that you want for your app needs, right? So one is cluster IP. So when you say service is of type cluster IP, that means that it's an internal IP, and that pod should be only accessible from internal to the cluster. So let's say you have deployed one app service, right? So which is exposed outside, but there is a database services which also is deployed. You don't want your want to expose the database endpoint of your service directly outside of the cluster. So wherever that database service is running, you would say the type as a cluster IP, right? So you want your database to be accessible only inside the cluster. So that way, depending upon the service, depending upon the app need, you would define your service to be either cluster IP or any other type. The other type could be node port. So node port means that the pod will get exposed through the node. So pod will be part of the node. So node itself will have one IP. So when you say a node port, here if you see the node IP colon port, right? So that means that that particular pod instance would get exposed outside of the cluster through a node IP. So there is one more type, which is load balancer. So let's say if you have deployed your AKS Kubernetes as part of a cluster on AKS or AWS, so using a load balancer, which is deployed already as part of that cloud, you can direct traffic through that as well. So in that case, you declare the type as a service. So service on a whole is responsible for routing traffic to your pods, right? So there is one more concept called ingress, which is on top of the service. But to reduce the complexity of the discussion, so I have just kept the service. So you can define more rules as well, like using ingress controller and that. So we can take that up in the further sessions when we do on the ingress concepts as well. So I'll just go to the config maps and secret. So config map is so as a name itself, right? So like it's responsible for configuration for your application that you are deploying, right? So let's say if you take .NET application, so it would have an app settings app setting file which you define, right, for reading the configurations. So whenever the pod comes up, it would be reading that configuration from the app settings files, right? So and that app setting file is itself part of the deployment code, right? So once it is bundled and deployed, you can't change the app setting file and let's say you are using some URL, right? So you can't change that app URL directly onto the code that you are deploying, right? So again, you have to commit that code, and then you have to create a build on top of it and then deploy, right? But it becomes a pain, right? Whenever if you have to change a configuration just for again for that, you have to do an entire deployment for just changing the configuration. So in that, to resolve those kind of scenarios, we have config map and secrets. So config map is basically it separates the entire configuration that you want to go into your pod, right, from the application code. So you will have app settings. Let's say I'm just taking an example of the .NET framework. So you will have an app settings that reads the configuration, but in that app settings file, you can inject the configuration that is coming from the config maps, right? So you will create services, and then you will create config maps or also for your service if you have like a deployable config that can be changed at any time. So here on the right side, this is like one of the examples, right? How you define it's in a declarative syntax, like key value pairs. You say mode is production time. So similarly, you would define all the configurations that are needed for your service. So, but you could, if let's say at some point of time you want secrets, let's say you are calling database, right? So you would have password and URL for it, so which you don't want to keep it as a configuration. You would want to keep it as a secret. So secret is also similar to config map, but there you have to like encode your data in the base 64 encoding. But generally it's not recommended. So since it's said that it's already encoded, so if you have like high secret values that which you want not to even encoded as base 64, then you will have to like keep it in some other secret storage like a key vault, and then you can mount that key vault into your deployment file. And that in the when you're mounted, and that at that point of time when application is coming up, you can read from that storage mount as well on the cluster. So this is config map, basically like separates your configurations from the app code to like and whichever configurations can be changed. at a dynamic time. And whenever you change a configuration, you just need to restart the pod, so that once pod is restarted, it will like pick the latest configuration from your config maps and secrets files. So you don't need to like again do a fresh deployment into the cluster. It's just that whatever pods are present, you just need to restart them. Or you can define through Helm as well, where you said like if one of these configuration changes, pod will auto restart. Right, so that configuration also can be set. So this is how like configuration maps and secrets help you to separate configuration and help you to like make deployments faster and application restarts in case any config changes. Right. So right. So the next component is volume. So whenever a pod, let's say pod is running on a node, and then for that pod you are processing something like a data or a file. In that case, let's say you need pod itself will support some kind of ephemeral storage and and a RAM for its needs, right? But let's say if you need more storage to push out the logs, or let's say you need more storage to push out files from the application code itself, then you would mount a storage as a volume. So there can be cases where you would need that storage only to be present till the pod is present. In that case, whenever the pod gets deleted, storage would also get deleted, which is a volume, right? So and let's say in case where you want a permanent storage, then you would have to create a volume which is supports data persistence. So there are like these are the different types. So empty directory storage means that this will get deleted when the pod gets deleted, right? So it's like a temporary storage. Host path means that the storage is created on the node on which the pod is present. Let's say you have a VM, right? So on that VM, which represents itself as a node, you have a pod running. So on that VM, you would mount a storage and attach it to your pod. So even when the pod gets deleted, still that storage would present on the VM or a host wherever you are deploying your pods. So the config map, which we discussed in the previous slide, is also mounted as a storage, so that and attached to the deployment file of the pod, so that it can read the configuration from that file, right? So config map itself also gets mounted as a storage, right? So that's about like quick introduction on volumes. And yeah, so now so deployments is a core where so whatever we have discussed in the previous slides, right, like the service or the volumes or the config maps, everything comes together as part of a deployment file. So deployment acts as a blueprint for your app, right? So here if you see, I'm on the right side on the spec, I'm mentioning replicas as 3, right? So this means that I want to have like 3 instances of my app, right? And let's say you have already containerized your application using a Docker or any other container platform, and you need to attach that image also here. So in the deployment file, and similarly you would mention service part of your which routes the traffic, right? The service instance also here in the deployment, and storage volume also you have to mention if you need volume storage, and then uh, and the replicas that you need, and the image details that you're where on top of which the pod needs to get created. So pod gets created on top of the deployment file, right? So whenever this deployment file is deployed onto the cluster for a specific app, all these details are read, like the network traffic ports that you want to route the traffic for using service, and then the number of replicas. So Kubernetes cluster would read like how many replicas are being asked to be created, right? So that also is part of your deployment file. So deployment file is like the main core part of your pod creation. So so if something is wrong in this part of your deployment YAML file, the pod would not be get created. So deployments is like we'll see as part of the cluster also, that deployments are also visible, and you can go into your deployment file and like modify the spec. Let's say at some point of time you need 4 replicas to be running, so you would like edit your deployment file, and as there is a change in the deployment file, cluster would observe, and then it will bring up the one more replica of your file for that. So when you delete a deployment file, it will delete all the pods that are attached to that deployment, right? So that is how it works. And like there are some other features which deployment also supports, like it will make sure the rollback happens if the deployment fails. Let's say you're deploying this and there is an unhealthy pod that is coming up, so it will make sure it will show you that stat as well. And then self-healing means that if you have said like you need 4 instance or 3 instance, so deployment will make sure that it's deploying that many instances of that application as well. Like I've said, like image here is my image, right? So it could be like a application image or or let's say data store image or something of like you have different services to be running. You would create like one image for each service, and that image you mentioned here, right? Yeah. Let me jump into the command line part of it. Right. So now let's say now your cluster is deployed using all the components that we have discussed, right? Like services and then deployment files and the config maps. Now, let's say now you want to see your what all are part of your cluster and are my deployments running, how many pods have come up or how many nodes are there. So one way is to use the command line tool, which is kubectl. So kubectl allows you to like each cluster by default will have a config file associated with it. So you have to download that config file for that specific cluster, and you have to set that context into your kubectl command line tool, right? So once you have set that context, so that kubectl will have the context to the cluster to which it needs to associate these commands, right? So once you set the context, so if you see here on the right side, the kubectl always interacts with the API server. So as we discussed in the master node part of the architecture, so API server is through which all the commands will get routed. So and etcd is the storage uh, which has the current state of your cluster. So let's say now I want to see how many nodes running. So all that data and how many pods are running, which pods are in bad state, and how many deployments I have currently running, right? So all that storage will present in the etcd as we as the current storage, right? So whenever you issue a command through kubectl, that will go to an API server, and through API server in the control plane, it interacts with the etcd storage, and it brings back the data from the etcd storage and to your command line response. So we'll execute these commands as well in the cluster setup to see the current store. So here, as in the, if you see the nodes and if you see the scheduler control, everything comes together as part of a cluster form, and kubectl can help you to not only see the current state, but you can like delete deployments, like you can restart your pods and you can delete the pods. You can check the pod health and everything, right? That like it has a vast set of commands. So we'll be executing few commands on the cloud shell of the Azure, right? So I have attached all the references here, and I'll share them in the chat as well. Before that, I'll go into the deployment for the cluster, right? Parth, any questions? Do we have any? Okay, cool. So what I have done is I have made use of this. So as it is like easier for me to share. So after the session as well, to everyone can go through this open doc and then deploy a cluster. So deploying a cluster itself will take some time. The cluster itself to come up on the portal. So what I have done is I've already deployed a sample cluster on my ID, personal ID, though I haven't deployed the code yet, but I have deployed the cluster. So here, if you see, you will be creating one resource group, and then as part of the resource group, and then which you want to associate your cluster. And then when you are deploying the cluster, since it's just for testing, make sure that you are selecting the type as dev and test and not production, enterprise, or production economy, so that it's just a sample AKS cluster, right? So once you have filled in all the details, like on the subscription, so I have a one test subscription on my personal account, and so I've created one resource group, and I've like given the name as a dev test, and here you need to give my AKS cluster, and again, like you need to just fill in few defaults, like you can choose any region of your choice. So I've also chosen as ECS2, and rest of the fields you can leave as a default set fields. So this cluster, it will take some time to get deployed. So what I've done is I've filled in these fields and deployed the cluster, AKS cluster. So not deployed the code yet, but I've deployed the cluster. So if you see here, so the name of my cluster is my MS Reactor cluster, since it's part of the session. So here, if you go and see whatever components that we have discussed, right, like workloads and services and ingress. So if you click on the service, the control plane itself would have been get deployed as a as a deployments on the master control plane, right? So whatever here you are seeing are the default control plane components that are required for functioning of the AKS itself, right? So if you go into the workloads, it will show all the deployments that are the default to the current control plane, right? So here, if you see like metric server and all the autoscaler, all these components have already got deployed, which are part of the control plane. So this all will be by default present on the node pool. So even if you can go into the settings and see the different node pools that have been created. So I created one node pool called np linux for code to be deployed. So you would see like agent pool is where all the master components are running, and control plane components are running, and np linux is where you can deploy your so here if you see like it mentions the mode as system. So system is where generally the control plane components run, and user is where your app code would run. So how do you attach how do you mention a specific node of type, right? So while creating the node, you would mention which type of underlying OS it needs, and based on that, here you could see the operating system as well. So in the deployment file, when you want to deploy your pod, there you would mention what kind of OS it needs, right, in the form of labels. So when the deployment is getting created on the AKS, then it will see which nodes are available of which of type, which OS that deployment requires, and scheduler will schedule the pod based on the specifications mentioned in the deployment file to that specific node, right? So if you open, like, you can see as well, like this is node pool, so it's a bunch of nodes that are part of this node pool. So you can like click on that and see here how many nodes are running as part of that node pool as well. Right, okay, so it seems to be some network lag. So here it's taking time to load. So I'll do one thing. Meanwhile, I'll deploy the code so that it takes time. So what I've done is I've taken the deployment file that is mentioned in this AKS learning path. Uh, so this is the deployment file, which would create like order service, storage service, whatever is mentioned, right? Like storefront, order service, product service, and order queue. So we have like one deployment file for each of these services. And like I have uploaded this file to my AKS cluster. Here, if you see, if I do a dir, I have a store.yaml which is already present here, right? So now I need to apply this store.yaml onto my cluster, so it would create the deployment. So So now it's now if you see like when we have clicked on apply, so on the particular YAML file, which is a deployment YAML, it is creating all these services and the deployment files which are associated with each YAML file, right? So now we can wait for all these deployments to be running by checking the pods it would create. So here there is one more command that is listed. So when you do get pods, it will like start listing all the pods that these deployment file would create, right? Okay. Let me bring this up. So now it's trying to create all the pods, right? So in the deployment file, we have mentioned that we need one pod for order service, one pod for product service, one pod for storefront. So we have to wait till all these pods get created. So meanwhile, we can check other commands as well. Like let's say if you want to check how many deployments have been triggered, right? So each service, like each pod that we are creating here, comes through a deployment. So we would have like 4 deployment files that are present, right? So we have like we have created one deployment for each service. So that's why it's showing that one deployment. So let's say now we want to see how many nodes are present, right? Then that for also you would say like get nodes it will show how many nodes are part of your cluster. So there's one AKS NP Linux pool and then agent pool, and which are like instances which are present of these pools. So similar way you can check and delete pods and delete deployments and as well. So let me check the current state of the deployments, right? It's one of our product service is still in creating stage, so let's wait for it to complete. Uh, Meanwhile, we can discuss if any questions are there.
No questions as of now.
No questions. Okay.
We have one question.
Okay. Oh,
Is it
what is that
replayable?
question?
Is there any
Yeah.
good video on
Is there any
networking?
good video?
Uh,
Okay, okay. So yeah, it's you can find videos in content on the Kubernetes learning path. So here, whatever I am sharing is just a sample deployment on Kubernetes cluster. So you will have specific learning paths for networking components of the AKS as well. If you want to dive deeper into that, so just go to AKS Azure AKS, Azure Kubernetes Service path on the Azure documentation, right? So you'll be able to find the learning paths for that with the sample cluster deployments. So now I'm executing this get service command for storefront. So it has an external IP already associated with it, right? So now if we click on this IP, if we visit this IP, it should give us the storefront. Meanwhile, I'll just check if all the pods have come up or not. No, still in container creating state. Somehow taking time, but let me check if this is accessible already. Okay, cool. Okay. So since that part of the pod is not yet ready, the service pod, product service, the products are not getting fetched, but still the IP of the storefront is accessible, right? Since the pod for the storefront, which is the last pod here, is running, so homepage is accessible. So let's wait for the product service to be run. Let me check.
Meanwhile, there is a question.
So
Would
we
you like
can,
to take it?
yeah, sure. What's-
One
Yeah.
pod is in
So
creating
what you
stage.
can do is right. So either you can go to workloads. So here workloads, here we see, right, it's stuck in the product service stage. So you can open that pod and check in the events. That is one thing. Or you can one thing it could happen is I'm on a test subscription, right? So I'm logged in with my test subscription. It could have limited permissions or limited credits. So I have deployed this cluster many times to check whether everything is working. So that credits might have gone over to bring the service that is part of the store, right? Or let's say RabbitMQ or the other parts which are required. So or it is taking time itself since it is deprioritizing since I'm on subscription. So one of this service, order service or product service, is having an issue with since I'm on a test subscription. So either you can go here, it's still in the container creating stage, it hasn't failed. So you can check the events or you can check the live logs also. So if it is in container creating stage, you will not have the live logs flowing. Live logs will flow only once the container is up and pod is running. Either you can check events or you can do one more thing. You can wait, or you can, if you delete the deployment, you will not find the pod itself. So make sure you're not deleting the deployment, you're deleting the pods which are associated part of the deployment, right? Okay, let me delete and try. So since we have uh, said, right, for this product service deployment file, we have said we need at a time one pod to be always available. So what it is doing is, even though we delete, it will bring back up one more instance, so that as it matches with the deployment file that we have deployed. Okay, so let's wait. We'll wait for some time. If it doesn't create, then I will have to go back and check if there is. Since it's a test subscription, I would have exhausted some credits. Uh, Meanwhile, if there are any questions, Parth, we can take those as well, since this is causing an issue.
So there is a question from Jeet asking how can we connect
Okay.
ARM templates to use within this script?
So ARM templates is a different thing. So ARM, let's say you can deploy AKS using ARM templates also, but kubectl, is it what he's asking is kubectl to be used inside an ARM template? Is that the question, Jeet?
I think he's given something like penguin blue
Oh,
ring deer.
or this something which is I have not aware of. I'll have
Okay.
to go back and check on this. You can ARM template, penguin blue. Oh, I'm not sure what is this part of
Okay.
the ARM template. Okay, so it is taking time. I'm not sure. This example might be issue since I'm on a test subscription, but storefront is still accessible. The homepage is homepage part of the service is still accessible, but it's seeing error in the fetch. So for that, so let's say now all the other pods are running storefront, and since products are not coming up, I'll will not be able to move forward from this part of the demo, since but other services are running. So can I can take the questions, Jeet. Sorry, Parth. I'll, since there is an issue, I'll have to stop the demo here. So instead
How to
of
configure
so
DNS?
every so in the deployment or in the ingress part of the configuration, you can uh, configure the in movement of the traffic for your cluster. So that part, or you'd have to like associate a load balancer part as well. So service name itself acts as a DNS, which is local to the cluster.
Okay. So one more question. Can you apply Flux GitOps plugin to AKS cluster?
So there is one more called one more variant called AKS automatic. So in that AKS automatic, it creates a deployment flow for your code. So let's say now you have a GitHub repo, right, for your code. So you can associate that repo with a cluster. So whenever there is a change in the code that you are committing, um, so that Git pipeline that is established through AKS automatic will make sure that there is a latest code that gets built and deployed to the AKS cluster as well. So that is also possible. Okay. I guess this is because my credits might have been exhausted. Okay, Parth. There are no questions, like we can stop here.
Great, Chaitanya. It was
Yeah.
a very good session and hope everyone had a good learning. Thank you so much,
Yeah.
everyone, for joining us today. Thank you, Chaitanya, for hosting it with Microsoft Reactor.
Yeah.
We'll have future
Sure.
events lined up as well. Yeah. Is
So
there anything
the
you want to? Yeah, yeah, yeah.
so the last thing is, since this pod has not come up for me, So what I would do is I'll just share the link of the quick start learning page that I'm using, right, for the
Okay.
demo in the chat, so that there are entire steps that are present on this template on the learning to get a subscription, and then creating all the steps that for AKS cluster, and then deploying the code that we just saw as part of the storefront homepage. It would, like, if they have like enough credits on their subscription, it would allow them to do the entire other deployment of the other services also complete. So I'll just share that here, so people can like go and out and give a try. Cool. Okay.
Thank you everyone. Thank you so much. And
Yeah,
yes, have
thanks.
a beautiful day ahead. Yeah, thank you so
Yeah,
much.
thank you.